need. I am Megan Souza, Marketing Manager here with Done Solutions Group. Before we get started, I would like to go over a few items. This session will be recorded, and we will send out a link to the recording to everyone who registered within 24 to 48 hours after the presentation. We also have recordings of all previous webinars on our website in the event that you missed any in the past at donesolutions.com. Also, if you have any questions during today's presentation, we encourage you to submit them, and we'll address as many as we have time for at the end of the presentation. If the question is somewhat complex and we need more time to answer, we do promise to follow up with you for those. So let's take a look at today's agenda. I will begin by doing introductions to Done Solutions Group. From there, I'll turn it over to today's presenter, Jose Hernandez, our Director of Analytics here at Done Solutions. Jose will discuss what a data lake is and why you need a data lake, and then we will go over questions and answers. So let's begin. Done Solutions is a digital commerce and business transformation consultancy focused on delivering velocity to our clients. Velocity is achieved by the combination of both speed and direction. Done Solutions helps our clients achieve speed by automating business processes and direction by using our advanced analytics. Our teams align with organizations to optimize their unique processes and help them discover the most profitable routes to business success. Done Solutions has a long history of delivering innovative business technology solutions. We are headquartered just outside of Chicago and have offices in Minneapolis, Raleigh, and Bangalore, India. Our offerings fall into two practice areas. Our application development solutions feature portals, e-commerce, and content-managed websites, mobile application development, and custom application development. Our analytics solutions feature analytics and BI platforms, as well as data warehouses, data integration, data lake, and IoT. We are authorized SAP, Liferay, and Microsoft training providers and offer classroom, virtual, private, and custom options. We believe that training is important because once we deliver a solution, we want to make sure that those who need it know how to use it and maintain it. Our clients, some of which are included here, are a combination of Fortune 500, mid-market companies, government agencies, and nonprofits across all verticals. About 80% of our business are commercial clients, 20% are nonprofit and government. We maintain strong partnerships with top technology companies in order to offer our clients the most innovative solutions available today. Our analytics practice helps deliver information to decision makers throughout your organization so that it runs better. We can help with decision making by not only looking into the rearview mirror, but also looking forward into the future by leveraging predictive analytics and data mining techniques. Our analytics and the cloud service offerings include data lakes, forecasting models, retail analytics, as well as migration services and a full range of data warehouse services. We are certified Microsoft Gold data analytics partners and leverage a full swath of Microsoft Azure platforms. And this allows us to deploy highly scalable and robust solutions for your organization on the Microsoft platform. As Amazon's web service partners, we also leverage a broad range of their platforms to build customized and successful analytic solutions, leveraging some of the platforms listed here in addition to others. We offer a global delivery model that gives us the flexibility to build teams that are best suited to your clients' timelines, budgets, and preferences. Projects that utilize offshore resources are always led by someone local and US-based. Thank you for allowing me to introduce you to Done Solutions. I will now hand over the presentation to Jose. Welcome, Jose.
Thanks, Megan, and thanks everyone for joining us today. So my name is Jose Hernandez. I am the Director of Analytics at Done Solutions Group, and the subject at hand today is pretty exciting, and I'm actually highly excited about the various concepts we'll be talking about. So much so that I have to do the best that I can to control myself today. And not get out of control. I will try to contain my enthusiasm a little bit, but I can't promise 100%. So to review what's left of the agenda, we're going to look at what a data lake is, and we'll also take a peek at why you need a data lake. Now, the one thing that I promised myself as I was preparing for this presentation is that I would not get too technical. I want to talk about concepts. There's a variety of ways that you can actually implement data lakes, and we'll touch upon them a little bit. But I conceptually want everyone to understand what a data lake is, what it's for, and what its purpose is. And so that's how we're going to get started today. Throughout the presentation, you're going to see some of these warning slides. And basically, I wanted to catch your attention with the word warning to let you know that this is a key concept or that we need to focus on and address. And you probably are aware, but I just want to make sure that you are, that today's data consumer is very demanding and he has very reason to be. And the reality is that in order for organizations to stay competitive today, you've got to make full use of your data. And it's not just data for the sake of data, but it's data for information. If we look at the data that we have today and the uses of that data, about 80% of your data consumers within your organization are probably using this data to keep track of key performance indicators and some of that operational data. They're basically scheduling reports, running reports, maybe looking at dashboards. And these dashboards are, the information on these reports and these dashboards is typically provided by the data warehouse. Most organizations do have an enterprise data warehouse, and I am going to use that as an anchor for some of the concepts that we talk about in terms of a data lake. Now, beyond those consumers, which are basically taking in some of this information, there's about 10 to 15% of your data consumers that are doing a little bit more. They're doing some deeper analysis and taking a look at trends that may occur within your data and looking at year over year, maybe month over month, things of that nature. They're even diving into some of the potential root causes of why numbers are where they are. And what they do is use BI tools, many of which you are familiar with, which allow you to visualize this information and basically dive into some of the raw data that comes from the actual systems themselves. They're not doing any advanced analytics. They're just looking for the descriptive component of what's going on. Now, the rest of your user community is the ones that are doing deep analytics, deep data analytics. And these typically involve data scientists. And data scientists are voracious data consumers. They can't get enough of it. And one of the problems that you've probably experienced is that your IT organization can't even keep them satisfied with the amount of data that they want. And that's part of what we're going to talk about today. All right, so let's look at these new savvy data consumers that we have, and they're not so new. I think some users have had demands on data for a long, long time, but it isn't until our ability to generate so much data as we have today that they didn't have a reason to be savvy consumers. There's so much of it now, and they want to get their hands on it. So they want access to information. And so the question is, what information? Well, they want it all. They want whatever data is available. And in fact, they may even want data that they didn't even think that they wanted yet. And when do they want this information? Now would be great, anytime. And they just don't know when they need it, and they need it just in time. And how much of this data do they want? Yeah, they want it all. They want as much as there is, and they want to get their hands on it. Now, so what are they doing with this information? Well, they're going to analyze this data, and they're going to use some tools. What tools? Well, there's a variety of tools that these consumers are going to use. There's so many commercially available and even open source tools available that they want to basically take that tool and have all that data that they could potentially have access to. And what kind of data are we talking about? Well, we're talking about all kinds of data. Notice I pulled this off without using any technology terms, but I want everyone to understand the state of mind and that data consumer has. And knowing that this is what they want and this is what they need, we'll then start talking about how we get it to them. Now, traditionally, there's a variety of technologies and methods that we use to store and manage data. And those techniques that have evolved over time and have served us very well over the years just don't work anymore for the volumes of data that we're talking about. And any of these savvy and voracious data consumers have to rely heavily on IT in order to get to that data. And by the way, there's a little thing that happens. If IT can't meet their demands in terms of data, they'll find a way to get that data and get it in-house through a back door, which isn't necessarily a good thing. So relying heavily on IT, this puts a big burden on IT to try to support the needs of this user community. And you know that IT typically controls access to the data, and there's processes in place and lots of rules and regulations about how to get to this data. IT is protecting the corporate data vault, and I use vault loosely here because there is a concept of data vault. That's not what we're talking about. And that access to that data is for a variety of reasons and for good reasons. You have to make sure that the data isn't compromised in a variety of ways. And getting access to this information is also very challenging across all the various systems. The data scientist that's trying to get at data doesn't know or care where the data is coming from. They just need to get to it. And getting access to all the sources where the data might live is technically very challenging. And the other thing, the closest I'm going to come to being technical on this particular slide is the concept of schema on write. All the data storage and management techniques that we have been using to date around this world relies on schema on write. In other words, what this means is I know the structure of the data that I know the structure that I want the data to be in, and so when I get this data, I want to put it in a particular schema. In order to have a schema, basically a format to this data, I have to know what the data is going to be used for. And this poses one of the challenges that we have today. I don't know how I want to use this data as a data scientist today. So having a schema that was predefined doesn't necessarily fill that void. So you might be asking yourself, well, didn't we build data warehouses to deal with all this stuff? And well, we kind of did, but a data warehouse doesn't necessarily fill all the needs of these data users. So the data warehouse doesn't provide just-in-time data. What just-in-time data is at the time that data scientist or that deep analysis person is going to go after the data, they need it. You know that in order to get data into a data warehouse that doesn't exist in the data warehouse, it takes a bit of time and a bit of effort to do that. There's a process to getting data into a data warehouse, and we'll talk about that in a bit. And having this requirement of lead time is detrimental to the needs of the data scientist, for example. The other thing is that our data warehouse is typically limited to the data that's required to measure a business process. And not all the data that we have access to is in the data warehouse. The data warehouse contains the data that is required in order to do analysis and measurements on a particular subject area or business process. Well, we simply just don't know the data that we might want or need to do some of our deep analytics. All right. So with all that said, and knowing that our traditional methods don't necessarily work for us, and our data warehouse doesn't meet the needs of that data scientist, we can rely on data lakes to provide relief. And yeah, I know this is a cliche picture of what they use for data lakes, but it is relaxing, and it does provide me a little bit of relief to see this picture. So I thought I'd share that with you before we get into what a data lake actually is. So let me introduce the concept of a data lake. And the data lake is all about democratization of information and making it accessible and giving the citizens that use this data also responsible. It provides our organizations with a cost-effective way to store vast amounts of information for later processing. We may not necessarily know what we want to do with that data, but somewhere down the line, boy, we're going to wish we had it so that we can do something with it. It also basically lets your researchers and your data scientists focus on finding that next big thing and not wasting time worrying about how am I going to wrangle this data. There is some data wrangling that still might have to happen, but the point is that in my data lake, if I put all the data that I possibly have, and we'll talk about boundaries around that, but the nature of a data lake is that if I got the data, I'm going to put it in here, and I'm going to keep it for all time, and it's going to be all of my data in its native form. So this basically allows me the ability to go after data way into the future and not worry about whether I collected it or not, because the data lake has it in it. So that's what a data lake is. But I want to do a little bit of history and talk to you about the origins of a data lake. And James Dixon of Pentaho has been credited for coming up with the phrase, or coining the phrase, data lake. And he came up with an analogy that's pretty clever, and we're going to relate it to our enterprise data warehouse. Our enterprise data warehouse is typically made up of data marts, and I want you to think of those data marts as bottled water. This bottled water has been processed, cleansed, and packaged for our consumption for a very specific use. It's to travel with this water that's safe and clean, and I can drink it, and I know exactly what I'm getting. I want you now to think of the data lake as a man-made reservoir of water in its natural state with no processing. And that's a key difference between these two things. So think about the bottled water versus the man-made reservoir of water. Think about the work that goes into processing bottled water versus filling up a reservoir of water for later use. That'll keep things in perspective as we go along. And so the purpose of having a data lake really revolves around the data consumer and making sure that we can feed those ravenous data consumers. It's got to be easy to consume, it's got to be easy to combine, and so with a data lake we can do that, and we can deliver the data just in time, all kinds of data. Data that we know we need today, data that we don't even know that we need today, but we have it, so we might need it, so let's keep track of it and let's store it. And also, the other thing that's interesting is that we'll worry about how it's going to be used later. We're going to store it in its raw form. However we got that data is how we're going to store it in a data lake. So in essence, we're going to apply schemas later. We're not going to worry about how we're going to use that data today. We're just going to track it. And the other important part of a data lake that we have to keep in mind is we always think about the storage aspect of it, but it also has to provide boundless playgrounds for not only to store the data, but to also process and manipulate the data. So that's another key important role of the data lake. All right, so I've got a new warning for you, and I'm going to take a drink of water here, so hold on, please. And every time a new concept or fad or technology comes out, people are always looking to replace something. And I'll make it clear right now that the data lake does not replace your enterprise data warehouse. The enterprise data warehouse is a part of your data ecosystem, and it plays a very important role that the data lake cannot fill. And so the data lake will not replace your enterprise data warehouse. In fact, maybe what we should do is take a peek at some of the characteristics and differences between these two, and you might be able to start gleaning some of the reasons why we need these two things. And we can almost go point by point on this, but I'm going to focus first on the data warehouse since we're very familiar with that. And the data warehouse, its purpose is to focus on business process. When a data warehouse is designed and delivered correctly, what it's in essence doing is giving you the metrics and the description around points of a business process, whatever that process may be. Order fulfillment, it may be inventory, it may be customer satisfaction. Whatever that process is within your organization, the role of the data warehouse is to gather up all the information around this particular business process so that you can do analysis on it and see why something happened. That data in that data warehouse, in order to get there and to be in a format that's easily consumable so we can use for that, is highly processed and highly massaged. If you think about all the source systems where we may be getting that data from, what do we have to do to it in order to get it into our data warehouse? We go through the ETL process, the extract, transform, and load process. It's a series of programs that have been written to do just that, to extract data from where it's coming from, to transform that data or apply business rules to it, to consolidate the data, to conform the data, to eventually put it into our target schema. That's a lot of work. It takes a lot of time to develop that code, and there's a lot of compute power going into making sure that that happens so that the data ends up in the warehouse as we expected. The data in a data warehouse is typically tabular and structured by its very nature, and we usually talk SQL to it. It's typically stored in a relational database that understands the structured query language, and that's how we get to it. In order to get this all accomplished, lots of effort, lots of design goes into it. And the whole point is that our target data schema is optimized for data retrieval in a very structured way, and your data warehouse is also very highly governed. So now you think about that, and you think about providing data to those corporate dashboards and to those operational reports, and you better believe it that the data that's in that data warehouse better be trusted, reliable, and right, because you're running your business based on that information that you're getting on those dashboards and in those reports. Now, if we look at the data lake, we think about a different use and a different point of view about that data. We're looking at somebody being creative or being in a research mode about getting to that data. So the concept of a data lake supports that. And what we want to do is we want to store everything. There are bounds that we set up. You don't just dump everything into your data lake, and we'll talk about that in a bit. But we do want to store all the data that we have access to. As we put data into that data lake, it's as we got it. It's unprocessed. It's in its raw form. If we got it from a source system, it looks just like the data as it was in that source system, and and we dump it into our reservoir. The data that sits in the data lake, unlike our data warehouse, can be made up of unstructured, semi-structured, and structured data. So we think about unstructured data, we think about things like audio files and video files and images. We think of semi-structured data, you're thinking about data that's sitting in a JSON or an XML format. And when you're thinking about structured data, think about your tables inside of a database, tabular structured information. So your data lake has to support all of this stuff, and it all has to live in the same environment. In essence, if I dip my toe into my data lake, I should be able to touch all those different types of data that are being stored in there. And the other thing that's very important to note about a data lake is that it's data for the citizens. There's a governmental aspect of it where somebody has to make sure that people are playing nice in the data lake, but the ownership of the data in the data lake and understanding about the data in that data lake belongs to the various data stewards throughout your organization. And so we all get to visit the lake and we all get to play on the lake and have fun on the lake, but we have to behave. There are rules. The other aspect that's important about a data lake, it has to provide lots of compute power. So it's not just a matter of storing that data, but it's applying that schema on read, and we want to make sure that our data lake and the way that we implement it allows us to do just that. All right, so let's talk a little bit about that compute power. And so storing and accessing the data is only part of the data lake's purpose. We also have to have the ability to massively process data in place. And so we're not just talking about storage of this data, but there's a variety of technologies that support the ability for us to, within that same infrastructure, process that data, whether we're going to run some predictive algorithms against it or do some machine learning or even apply schema on read. This is something that the data lake has to support. Another important part about the data lake is that it literally has to grow or shrink, not just on demand, but almost without us noticing it. And the idea is that I don't have to worry about all the plumbing and the pipe required to do this. If I have to load in data into my data lake as a citizen using the data lake, I can do that. As long as I'm following the rules, whatever those rules might be, I can go ahead and load up data in that data lake, and I know that that my data lake is wide and deep and can store all kinds of information and support that. Another important aspect of a data lake, since we are talking about large volumes of data, we have to be able to onboard that data very rapidly. And the data lake's very nature helps in doing this. Since we're storing data as it is and we're not heavily processing that data, most data lake implementations allow us to quickly load up that data into the data lake. So that typically is not a problem. All right. So now I want to talk a little bit about the philosophies or the way to look at the world when you're thinking about, hey, what's the role of my data warehouse and what's the role of my data lake and what's the right thinking in regards to these things. When I talk about my data warehouse, the data warehouse uses a top-down approach and logic. It's basically using deductive logic, where basically from known rules and principles that are generalized known rules and principles that are known to be true, we define a specific true conclusion. So if you think about what's happening in a data warehouse where I'm getting data from trusted places, I'm doing some massaging of the data, and I'm loading it into my target schema, all those things are known, all those things are true, and I am basically making sure that the data that's in there is very descriptive and diagnostic in nature. Now, that's part of what I have to do in the world of working with my data. It's very informational in nature, and it tells me a lot about looking in the rearview mirror. But when I think about predictive analytics and trying to guess what's going to happen, it's a slightly different approach. Here, I'm basically looking at specific instances and trying to generalize a conclusion. And the key word here is I'm trying to predict. And when I'm trying to predict, I might sometimes be wrong, I might sometimes be right. And that's a key difference between the use of a data warehouse and the use of a data lake. The data lake supports a research environment where I'm trying to come up with ideas and things and be able to support it, where my data warehouse is my one version of the truth, or I'm guaranteed to know that what I'm getting out of my data warehouse is the truth. Okay, so besides the pretty picture of a restful, peaceful lake, let's take a look at what a data lake looks like, and this analogy that kind of sticks along with the lake metaphor. And so my data lake is a large man-made repository of water, and that water that's, or of data, let me say, and that data can come in from a variety of ways. Let's talk about what those are. So let's first talk about data ingestion and the data that ends up in my data lake. That data comes in typically 3 different forms. I might have structured data, semi-structured data, and unstructured data. And what that means is, and we talked a little bit about this already, but my structured data is data that I'm getting from systems which have basically tables made up of columns and rows in place, and I'm loading that up in tabular format inside of my data lake. Now, if you think about this, as we talk about these other sources of data, it sounds like, well, that's kind of interesting and challenging. So I'm going to put structured data in along with this other semi-structured and unstructured data. You might be thinking there's no database that actually does that. And you're right. None of the relational databases that you're probably accustomed to using for your operational systems, your transactional systems, and your analytical systems would support all this stuff. So that's kind of interesting. So the semi-structured data. If you think about data that's coming from Internet of Things enabled devices or anything that generates XML or JSON type files, that's what we're talking about here, where there is some structure to the files that we're dumping in here, and the structure is embedded within that particular file that we're dumping in here. But it's not the same as that tabular data that comes from my structured data. And finally, my unstructured data, where video files, audio files, pictures, emails, social media information, potentially. These are data that I have no idea what the structure is going to be, but yet I still want to use that data and possibly incorporate it in things that I'm doing. So that's what the intake component of my data lake is. And remember, I have to be able to load up this data fast, and it has to handle all the different types of sources. All right. So now let's talk about consumption from the data lake. And this is where it gets fun, because, and I've been trying to make analogies with a lake and sailing out on the lake and so on. But really, the best analogy I can come up with, better than a lake, is a playground, or even a sandbox. That's an even better analogy. And if you think of this data lake as a place where everyone gets to go have fun in the sandbox, and basically potentially use the same sand or have designated boundaries around their sandboxes, but it's all coming from the same place, they can go and use that data in a variety of ways. They can even add data to the data lake, assuming they're given, we'll talk about rights and restrictions in a bit, but it's a place where I'm not restricting the user with tight controls. I'm giving them an environment where all that data lives and they can do all kinds of things using whatever kinds of tools they want to use. In fact, it's interesting to note that a consumer of my data lake might even be my data warehouse. So it's kind of an interesting thing. We'll talk specifically more about that later on, but note that a consumer of the data lake isn't necessarily a human trying to do analysis. It can be other programs that need to consume this information as well. Which leads me to my next warning before we get into the final square of that picture that we're going through, is not to let your data lake turn into a data swamp. And just to be clear, a swamp is full of stinky, stagnant water that nobody wants to drink from, and nobody should. And you want to guard against your lake turning into a swamp because it could happen. And what we need to realize is that the data lake is not the wild, wild west. Governance is still needed, and the governance though is shared between IT and the citizen users of the data lake, basically the citizen data stewards. The data belongs to the individuals. The infrastructure belongs to IT. That's the way to look at it. IT makes sure that the data lake is running, that it's working properly, that it's accessible. The data that's in that data lake, and they may even be involved in putting in data into the data lake, but how that data is used, what that data is really up to the data stewards throughout the organization. So you have to identify who is going to be responsible for the information that's in there and the quality of the information that's in there. And that's not IT. IT can make sure it's running, but IT doesn't know the data as well as the business community knows the data. Now, we talked about data that's in your data lake, but data in the data lake also includes metadata or data about your data, information such as, hey, when was this data introduced? When was it last modified? Who put it in here? Where did it come from? That kind of information is also important to have in a data lake, because if you think about vast amounts of data, it would be good to know where it came from. It gives you an ability to find it and search for what you're actually looking for, because there is quite a bit of it. And the other thing to keep in mind is whatever you dump into your data lake is going to impact your data lake. So don't contaminate it with bad data. Know where you're getting that data from. Know that it's coming from a reliable source. And even though we can load up all the data we want into a data lake, there are some boundaries that you need to set. You need to talk about relevant data that serves some kind of purpose. Obviously, if it's data that has nothing to do with what your organization is doing, it shouldn't be in the data lake. So having all the die-hard movies sitting in your data lake, unless you're doing analysis on movie going, probably isn't a good idea. And the other thing that's important is have a vision for your data lake, know what you're going to be using it for. And by the way, we don't have to have just one data lake. You could actually set up multiple data lakes, but we're primarily focusing on having just one of those, and make sure you have vision and goals around what its purpose is. Which leads us to the final component, security and governance. So these are the things that will help us make sure that our data lake does not turn into a data swamp. It is a playground, but even playgrounds have rules. And so when you're at this playground, if you're not playing by the rules, you will be escorted out. Don't throw sand in the other kid's eyes. That's a very bad idea. And even though the data lake has all this information in it, not all the information should be available to all the users. There still is the concept of, it's for the appropriate eyes. And if you are deemed to be able to consume that data, then you will be given rights to that area of the data lake where you can get that data. And also note that some data may be sensitive in nature, and there are laws that govern the use of that data. So the data lake has to support that as well. So security has to support that as well, which can include encryption of that information sitting in your data lake. So that's something, if you're in a regulated environment, or if you're storing credit card numbers and things like that in your data lake, make sure that your data lake deployment does allow you to encrypt the data. And the data that we do put into our data lake, let's make sure it's not of poor quality. It's good quality data that came from a trusted source. I'm not saying that there can't be zero problems with the data. Data is not clean, but the overall feel of the data is that it's coming from a trusted source, and when you're using that data, you can rely on what's going on within that data. All right, so let me take a breath here and do a time check. All right, we're doing okay on time. And we're going to focus our attention now on you need a data lake. And if all these descriptions so far haven't given you ideas as to why you need a data lake, I'm going to like pound a few of these down, and you'll see why you need a data lake. So let's start with our voracious data consumers, and that 10% of those users that are using it for deep analysis and for data science. For your organization to not just survive, but excel today, you are going to have to rely on the data that you have, innovation, efficiency, finding the next best thing, keeping your edge. And in order to do that with vast amounts of data, you have to find meaning in the data. And it's very challenging to do that without your data scientists being supported with the information that they need. So when we think about achieving those goals, we've got to make sure that your data scientist has all the information they need, and they have to have it in such a way that it's easy for them to get to, and whatever data they might need is there. So your data scientist has to work on things like predictive analytics, prescriptive analytics, which basically is, let me do that definition real quick. Predictive analytics basically tries to forecast something, whatever it is that we're trying to forecast. Is a transaction fraudulent? Is a customer going to churn? We try to anticipate and predict, given the data that we have, whether those things will happen. Prescriptive analytics goes a step further. It certainly relies on predictive analytics, but it then goes ahead and makes a suggestion, and when automated, actually invokes an action to circumvent the bad thing that you predicted was going to happen. So it's not necessarily a bad thing, it could be a good thing as well. A classic example, if somebody is on an e-commerce site and they're putting some products into their shopping cart, then all of a sudden certain recommendations are made to them about things that they might want to consider. That's prescriptive analytics, it's a recommendation engine. And based on who that customer is and how they've acted versus how other people like them have acted and what's in your catalog, this recommendation engine is going to go ahead and suggest to the customer what to put into their shopping cart that might be relevant. Pretty cool. They're going to do machine learning, which is basically a form of artificial intelligence, which may be very appropriate. They'll help you out with experimentation, A/B testing, for example, and basically qualitative data analysis to back up gut feels and hunches that you might have, so that it can help steer strategic decisions. So your data scientist is very valuable, and they need a way to get to that data, and a data lake is a way that they might do that. So we talked about a data lake potentially working with and providing data for an enterprise data warehouse. And this is a scenario that I want to talk about. So reiterating that your enterprise data warehouse is a home to all your historical data, metrics and dimensionalities, or to provide information for your key performance indicators, your performance indicators based on business processes. That's what the role of the data warehouse is. And how it does this is by extracting data from your various transactional systems and loading it up into a model specifically geared towards this. So you've got your data warehouse, you've got your dashboards, all this cool stuff that's happening for your organization. And somewhere down the line, maybe years later, you identified that, gosh, it would be awesome if we could measure another KPI and something that we should have been tracking that we haven't been tracking. Well, years have gone by, your data warehouse has been populated with data specific to the KPIs that you cared about, and all of a sudden you've got this KPI that you want to worry about. Today, if you want to include that into your data warehouse, you are basically start collecting that information from that point in time forward, and which is great, and that's how we traditionally have been doing it. But if you wanted to know what that KPI was prior to the day that you started collecting it, you're kind of out of luck. Just wish that you would have identified that a little bit sooner so you would have been capturing that data. And the reality is that many systems are transactional systems may be purged or the data or the history lost because they're not meant to potentially store all the historical changes that occurred in the data. So you can't go back in time to do this. So imagine that you could go back in time. So in the scenario that I just described, we didn't have access to all that historical data because we simply weren't capturing it at the time. The data warehouse does capture historical changes, but only the ones that only for the things that you are actually capturing at the time. And if you think about the staging area for an enterprise data warehouse, it is transient in nature and typically goes back a short period. The staging area for your data warehouse is where you load up your data so that you can then process it and load it up into your target schema. And the lifespan of that staging area, depending on the environment, might be a day, it might even be a month, but seldom does it go back much beyond that. There are instances where you may go back further than that, but it doesn't typically happen. So I can't rely on my staging area to do that. Besides, you can imagine how large your staging area would be if you kept all the data all the time, every time that you were doing an extraction from the sources. It would grow very large, and your databases probably wouldn't be able to store all that. So if you had a data lake, the data lake would give your data warehouse the ability to go back in time. Because remember, your data lake stores everything whether you thought you needed it or not. So the data lake can serve as a great staging area for your enterprise data warehouse. This will allow you two things. Number one, if you come up with something in the future that, gosh, you wish you were tracking all along, that information is probably going to be living in your data lake because you've been storing it all. The other thing, if your data warehouse catastrophically got corrupted, sure, you could probably try to rely on backups. Hopefully you've got them and they worked. But since you've been storing all that data in your data lake, you'd be able to reconstruct your data warehouse from the beginning of time, of the data warehouse at least. So there's a lot of benefits that a data lake can provide for your enterprise data warehouse. All right. The next warning that I have for you is deploying a data lake is expensive and challenging. So my advice to you is don't deploy a data lake. Sounds counterintuitive. I've been telling you all along that you should build one of these things. I said you should use one of these things. I didn't necessarily say that you should build one of these things. If you think about the data centers that would be required, and you might have within your organization quite a large data center, it would have to be larger. And there's no reason for doing that today, because today, if we were going to build a data lake, I would highly recommend that you do it in the cloud. And when you build your data lakes in the cloud, you have a lot less to worry about. In fact, you can spin up your data lake now. It would probably take a matter of an hour or so to spin up your first data lake, as opposed to having to acquire the required hardware for your data center, install software that you would need in order to deploy your data lake. The cloud's waiting for you. And there are two cloud offerings that we support, AWS and Microsoft. They have great data lake bundles, I'll call it, that easily scale. You only pay for what you use, whether that be in storage or compute. It's reliable and trusted. Many of the systems that you use today yourself are probably based on these two vendors. And they have tons of supporting tools to support the data lake and its usage. So don't build it yourself, spin it up in the cloud. That's the way to go with data lakes. All right. Now, the other reason you want to build a data lake is you want to delight your data consumers. And the one thing that you will be very happy if your data scientists are very happy. And basically, if you want to give the information that your data scientists and your analysis team needs, a data lake can do that for you. And you don't have to start big. You can start with a pilot project and a data lake. I was going to say a small data lake, but that doesn't really matter because by its very nature, the data lake can grow as you need it, but you don't have to dedicate an entire big project in order to get this thing started. You can start seeing the benefits of a data lake through a small POC. And we can help you get that started immediately, and your data consumers will be very, very happy. If you're, by the way, obviously there's a little bit of sales associated with this presentation. If you are interested in seeing how a data lake can help you and your organization, certainly by all means reach out to us at info@dunsolutions.com, and you'll see that my email address is out there too, so you can certainly reach directly to me, Jose at dunsolutions.com as well. So with that said, and hey, I did okay, 11:56. We have a little bit of time for potentially some Q&A, and I will see if, Megan, are there any questions out there? Nothing at this time?
Not at this time.
All right, very good. Well, here's the thing. You have in this presentation, which is going to be put on our site, you do have a way to reach out to us. If you come up with any questions or concerns about data lakes and you want to know how they can help your organization, by all means, reach out to us and we'll be happy to talk to you about those. We're very excited about this concept and the great things that organizations can do with their data lakes.
Thank you, everyone, for joining us today. We hope to see you again in our future webinars. We will be having more about data lakes as well, so we'll make sure that you receive the invites for those. We hope you enjoy the rest of your day.